Alright, so here we are, and what we're going to do is we're going to graph this quadratic equation. So when we are graphing quadratic equations, the first thing we always want to think about is our negative b divided by 2a. Now what this negative b divided by 2a does is it tells us the x-coordinate of our vertex. So we're going to need to find that first to get this process started. So I'm going to look at my b value. I see it's 12. Now the formula asks for a negative b, so I'm going to make it a negative 12 here. I need to divide it by 2 times what our a is. And I see that our a is a negative 2. So once we have this set up, we realize that what this really is a negative 12 over a negative 4, which tells me the x-coordinate for my vertex is a positive 3. Now, to find the y of our vertex, the y-coordinate for our vertex, what we're going to do is we're going to evaluate our original equation. Right, and we're going to evaluate it when x is equal to 3. That'll tell us the y-coordinate point for our vertex. So I'm going to take our original equation. Everywhere that we have an x, we're going to replace it with our 3. So now, we have it set up and we're going to evaluate this piece by piece. So this first one, you take care of the exponents first. So 3 squared is 9. We multiply that 9 by the negative 2 to get a negative 18. Then once we look at the next piece, this is a 12 times a 3, which gives us a positive 36. And then we have this negative 17. So we're trying to put all these terms together here. This is the end of our evaluation process. And when we do that, we recognize that this all comes out to be, and you can put these together in any order you want. So maybe you could do the negative 18 and the 36 to get a positive 18. 18 minus the 17 tells us that the y-coordinate for our vertex is equal to a 1. So now that we have our vertex, we can go and plot it onto our graph. We go to 3, we go up to 1. That's our starting point there. All right, we can take it and put it into the middle of our table as well. So we have our vertex at 3 and 1. Now our y-intercept is always our c value. So I'm going to go and know that the y-coordinate for my y-intercept is that negative 17. And since we are on the y-axis, we haven't gone anywhere in the x direction. Our x-coordinate is always a 0 when we're talking about our y-intercept. Now, so this y-intercept does not fit on our graph, so we will not be able to use it and its symmetry to plot us some points. So what that means for us is we're going to need to use our table to find out some more points. Now, we know since we have the vertex in the middle, that these y-coordinates will be linked by symmetry, and these y-coordinates will be linked by symmetry. Okay, so all I'm going to have to do is choose 2 of those to evaluate. Alright, so what I'm going to do first is I'm going to choose to evaluate this 2. Because the 2 is going to be easier than evaluating with a 4. It'll keep our numbers smaller. So here's me evaluating when x is equal to 2. So I'm going to use our original equation. Everywhere that we have an x, I'm going to replace it with that 2. So once we get this set up, we're going to go through and do the same evaluating process. So I look at this first piece here. I see that 2 squared is a 4. That 4 times the negative 2 is a negative 8. Then we get a positive 24. And then we have that negative 17. So when we put all of these together, we are going to end up with a negative 1. So I'm able to fill in both of these spots on the table with that negative 1. And if you want, you can go ahead and plot it. So at 2 we have negative 1, and at 4 we also have negative 1. So we see our parabola starting to shape up there. Now what's left over for us to do is I'm going to evaluate at this 1. I could also evaluate at 5, but to keep the number smaller, I'm going to evaluate when x is equal to 1. Still using that same original equation. And everywhere we have an x, we need to replace it with a 1. So taking it term by term here, 1 squared is 1 times the negative 2 gives us a negative 2. Here we have a plus 12. And then we have the minus 17. So when we put all of this together here, we will end up with a negative 7. So that fills in both spots on our table. And we can plot that. So I'll go to 1, and I'll go down to a negative 7. And we can go to 5, and we can go go down to a -7. All right, now we see the symmetry here passes through our vertex. Notice how on both sides of this line of symmetry our points are the same distance away. That's one way you can check to make sure that your parabola is correct. So once we have our points there, we go through, connect them, make a nice smooth curve with our parabola, and there we are. So that's what it would look like. So using our table, we plotted the points. Using our vertex is how we started it off. So now what's left for us is to discuss the domain and the range. So we'll talk about the domain first. So domain is all of the possible x values we can have. Now if we think about these, the arms of these parabolas, they will continue on to the left and to the right for forever and ever. And what we call that for our domain is we talk about it in terms of -infinity to infinity. Right? Our x values can go anywhere. They will extend on for all times. Now the reason we're not putting a line under our inequality is because we cannot be equal to infinity, because it's not a number, it's just a concept. Now for the range is going to be different, because we see that we do not encompass all of the different y values. We know that range talks about y, so let's talk about what values. The arrows pointing down here, they will continue down for forever and ever. So its lowest value we will call -infinity. But when we look how high that this equation goes, we notice that it has a vertex, it has a maximum point right here at the top of the parabola, and where it's located is 1 in the y direction. So we'll call that our maximum value for our range, and I will put a line under the inequality because we are allowed to be equal to 1. That is where our vertex is at.